Good morning, everybody, and welcome to Xbox 360 Indie Game Design using XNA. Yay! Yes, I'm blatantly going for applause because it's early in the morning for me. The point of this is we're going to try to quickly go through and show you building a very simple game from beginning to end, which is a very tall tale, so I will speak fast and use a lot of smoke and mirrors. Feel free anytime between now and tomorrow evening when I drive back to Alabama to stop me and ask as many questions as you want. I have no problem setting this Xbox up in my hotel room and showing you example code there, etc., etc. We'll make sure you get the content you need. But it is a tall tale to write a game in an hour. So, to begin with, we have to pay the bills. Recruit-wise, as far as I know, that's the only way to give speaker feedback that I found so far, so feel free to do their little tweet thing there. Go talk to their booth. Without them, we wouldn't have this lovely building. Rocks Press, hey, I like books, you like books, we all like books. Go buy a book. Yay! Alright. Alright, were any of you in my session just a second ago? Okay, yeah, you're going to recognize some of these slides because they were both XNA talks just for a different target. However, there are some things that are specific to this one. The first thing we're going to do is we're going to talk about some necessary things. We're going to talk about the app hub, getting your Creators Club account, a few things like that if you're actually going to need to get started. Then we're going to actually talk about the game fundamentals, the things that every game, every XNA thing is going to have in common. And then we're going to slam through a demo where, with the remaining time, I'm going to show you how to write a game. And unfortunately, since I forgot the power supply for my KVM, we're going to write all the code, and then you get to see it working once. Sorry. So, necessary tools, necessary resources, everything you need to know. It is worth mentioning that no, I do not have licenses to any of these images. I go to Google Image Search, I type in something that makes me think of what I want, and I steal a picture. So, yeah. License now. Okay. XNA Game Studio 4. It is either available as a standalone product or it is bundled with the Windows Phone developer tools. It integrates into Visual Studio 2010, and it integrates into any version of Visual Studio 2010, including the Express Edition of C#. So there's no excuse, you know, you can get the free version. It's happy. It supports development for Windows Phone 7, for Xbox 360 games, and for Windows games. When you look at a project, you'll be given the option to either do Reach or High Def. The Reach graphics framework will work with any device. The High Def will only work for the Xbox 360 and a really advanced Windows graphics card. And to express this fact, I cannot run the High Def profile on this laptop. So yeah, I mean, it takes a bit of a crunch to actually be able to do it. I'll show you where that option is, but I'm not going to go into any more detail than that because there is an entire talk on that tomorrow, and you should go sit in that talk if you really care. And no, it's not me giving it. For some historical references, the previous versions, as you notice, Game Studio revisions come out with Visual Studio revisions. The only thing really worth mentioning is that you actually could write Zune games in Game Studio 3, and they actually took that out in Game Studio 4 because nobody did it. No one. And I only got as far as I can pull my jacket out and pull my Zune out, and there's a little thing where you can see me move the touchpad around, and it shows the XY coordinates, and that's as far as I got now, and I can't think of any reason to use this. Really. As far as the features that you can use, avatars are fully available. You can use the Xbox Live player's avatar. There is a bunch of rules of what you are not allowed to make them do. You can't make an avatar kill another avatar. You can't make an avatar drink. You can't, you know, etc., etc. But other than that, you know, do whatever you want with them. You do not have access to achievements. The reason being is because I don't want a bunch of people making indie games where you hit start and you get 1,000 achievement points. Repeat until dead. You do not have network access. I don't know why. But yeah, if you've ever noticed Xbox Live indie games don't have online leaderboards, it's because you have no network access within an Xbox Live indie game. We're trying to get this fixed, especially since the Windows Phone XNA support actually does have network support. Matter of fact, that we actually hit a web service during my talk this morning. As far as the Kinect goes, the status is unknown. We know they're making a Windows SDK. I think there's a talk on Kinect. I know there, at least originally, was supposed to be a talk on somebody programming with Kinect. Just did it? Yeah. I knew there was one. I didn't know. The XNA team has not said yet whether or not they're going to port the SDK into XNA. Their justification is they want the XNA framework to be very managed and very user-friendly and et cetera, and they don't know if they can make the SDK do that. So we don't know if we will ever get Connect support. The App Hub is your one-stop shop. It used to be the Creators Club. It has all your Windows Phone 7 stuff, has all your XNA stuff. You got software downloads. It's where you can actually get the developer tools and whatnot. Sample code. There's an extensive set of forums. If you actually go into the forums and find the Game Studio forums, you'll see me all over the place. You do have to create an account. Okay, the actual membership. It's $100 a year. If you are a student, you can get a free year. If you have a .edu email address, they'll verify the .edu email address. It's actually through DreamSpark, and you can generate a trial code. You can't publish anything, but at least then you can copy code to your Xbox, which is all you're really trying to do anyways. For all you people who like playing Rock Band and want free Rock Band tracks, that's a good way to do that, because you can copy the code over. You just can't publish it. You can publish 10 games a year. You can publish 5 phone games a year. You can actually publish unlimited number of free games. You can publish 5 that you can charge for, I think is the way it works. And then, like I said, you can copy codes to your Xbox 360. You can also unlock a developer phone if you've got unlock a Windows phone if you've got a membership. And you get access to the code peer review and the content review. Indie games do not go through the ESRB. I mean, you could put one through the ESRB, but it costs a lot of money, and it would come out of your pocket. The way they get around that is they have peer code review. When you're done with it and you've submitted it and it's been accepted that it can go in the marketplace, you can actually download all these games before they come out, and you play through them, and you say, okay, I think its violence level is a 1 through 3. I think it's, and you kind of give it some content modifiers, and that becomes its rating, and it's kind of done through the community. I think it takes something like at least 10 people, and it uses an aggregate score to end up doing your rating. Oh, I forgot to mention, I didn't put it on the slide. You actually can get a 3-month membership. It's $40 for 3 months. Once you've actually become a member, then you can actually go to the console. When we actually get to the console part, I'll show you where it is. You have to get the Creators Club software. Go into the Xbox Live Marketplace. In the Xbox Live Marketplace, under the game add-ons, you will find the XNA Creators Club section. From there, you can download the XNA Game Studio Device Center. Or you can download the XNA Game Studio Connect. That's the actual piece of software we will be using where you can actually debug programs on the Xbox, and it's also the one you use to copy the program over. The XNA Game Studio Device Center is what you have to use on the PC. I'm not going to step through all of this registration, but the basic idea is that when you install Game Studio, not XPS viewer, go away. When you install Game Studio, where are you? You get the Device Center. See here, I've got my Xbox list. You say add device, it gives. I don't remember which way it happens. You say in the program on the Xbox, you say I'm adding device. On here, you say I'm adding device. One of them gives you a code. You type the code in on the other device. I think the Xbox gives you a code because computers have keyboards. You type in the code, and then it basically searches the entire subnet until it finds the device that has that code listing for it, and then it creates a relationship. And then it registers in there. You just have to do that with Zunes too. This is where you would register a Zune if you wanted to get Game Studio 3 and do that. Yeah, and then go it from the device. Alright, so let's actually talk about some XNA, shall we? In your general architecture, you have a game class. The game class is what contains the game loop. The game loop is what your game runs. The game class will have a constructor. After the constructor, it has a function called initialize, as it's called. That's where you would generally add all your game components. We'll talk more about game components in a minute. After you do that, then you would load all your content. This is where you would load your sound files, your fonts, your images, etc., get them all loaded into the program so that you can manipulate them. Then you get update and draw. Well, that's where most of this talk is going to be about. And then at the end, you have unload content. Unload content is generally if you have external managed code, that's where you would actually unlock it. You'd unload it. You don't actually have to unload your images and stuff. That'll happen for you. Update and draw can run simultaneously in separate threads, but they don't necessarily do it. Here's what happens. At the beginning of your program, you can decide to lock your frame rate. If you lock your frame rate, then it's not really separate threads, but update and draw run independently. By general convention, when the game starts, it runs initialize, it runs load content, and then it runs update, it calls update, it calls draw, it calls update, it calls draw, it calls update, it calls draw, in a circle, ad nauseum, until you call exit, in which case it calls unload content. If you lock down your frame rate, it sets up a trigger where it calls draw, it waits until that period of time, so when the next frame should be done, it calls draw on a steady pulse, and then it calls update immediately after each other call. What happens is if you do that, there is a flag inside the game timer class that I'll show you, but I don't really use too much in this example, called is running slowly. That is set to true if update is taking longer to draw than one call to update is taking longer to run than one call to draw. So it gives you an opportunity to let the game catch up by saying, I don't need to update this, I don't need to update this. You can actually, change how often you're calling things if the game's running laggy. If you do not lock down your frame rate, then it just recursively goes around. You'll never know if it's running slow, etc., etc. It just goes. As far as update is where you're going to move around all your individual pieces, which means that's where you need to query the keyboard and whatnot. The gamepad, there's actually a graphic of it on the screen that we'll get to, but it's one of these. There's a enumeration built in called player index. So player index 1, 2, 3, or 4 is controller 1, 2, 3, or 4. It's based on the indicator lights on the controller. I'm sure most of you have seen one of those before. If you're dealing with something that's an actual button, which means any of the 4 directions on the D-pad, start, back, the big Xbox button, which I think you only get access to as an event. You don't actually get it as a button press. The left and right buttons in A, B, X, Y. They are... you would think they would be just simple booleans where it was true if you're pressing it down and false otherwise, but no. They have something called a button state. You query the button state and you'll get back an enumeration that tells you whether it's either pressed or unpressed. There is no on-click. So, and I'll show you the code that does this, but generally speaking, you have to say if it is now pressed and on your last call to update it was not pressed, then they press the button. So you actually have to manage that manually. If you're dealing with an analog control, which are the 2 analog control sticks or the 2 triggers, then you actually get a float. Everything in XNA uses floats. It will drive you crazy because you'll try to say 1.0 and you'll get type mismatches because you tried to put a double into a float. So yes, everything is 1.0F. Remember that. So you can call thumbstick left, right, you'll get a vector 2. Which will tell you at the XY position from -1 to 1. If you're doing a trigger left or right, you get the from 0 to 1. So it's either completely up, completely down, or some in between. As far as the keyboard, if you just call a keyboard get state and you were doing a Windows game, then you would get the complete button. Everything on the keyboard is a button. And you can query the state for up, down, left, right, etc., etc. The reason I mention that is there's also an overload to get state where you can pass in a player index. So if you say keyboard.getState player index 1 and they have a chat pad attached, that's how you get the buttons off the chat pad. So you can't say I didn't tell you about it because it took me forever to find that. There's your Xbox controller. That's what I mean by the Y-axis, the X-axis, whole 9 yards. The reason I put this screen there on like this is because of what's coming up on the next screen. And I know what's on the next screen. But notice, Y is up, X is right. Just like it's true and natural in the world and what you think of. And like, Descartes is all kinds of happy now because you're using a Cartesian coordinate. Everybody happy? Notice the screen coordinate. Top left, Y goes down. So yes, if you press up on the controller, and you straight pass that through to the game, then you're going to go down. Now, if you're playing a first-person shooter or a flight game, you probably want inverted controls. Any other time, you don't. So that's another one of those things that will drive you crazy until you realize what's going on. You actually can query the position on the screen. This is kind of just thrown in there for reference. It's graphics device, which is the global object of the game component, .viewport, .width, and .height. The viewport is the section of the screen that is actually being viewed. When you're dealing with your standard 2D game like we're going to be dealing with here, you basically paint everything into the viewport. But what you can do is create a nice big level like Super Mario Brothers, and then the viewport is the section of the level you're looking at, and you can move the viewport. So that's one of those. There's more than one way to do it. And if you're dealing with a 3D game, which I'm not even going to bother trying to touch 3D in a beginner's talk, but what you actually do is you render the entire world, and then the viewport is the camera, and you move the viewport around the world. Components. Components act like a mini game loop. There are two types of components. You got drawable components, and you have non-drawable components, which makes you go, why would you ever want a non-drawable component? Well, you'll actually see a non-drawable component. You'll also see lots of arguments in the forums about people saying components are evil. I will briefly discuss that in other parts here and there. I don't think they're as evil as other people tell. But by default, when you say, I want a new item, I want a new game component, you do not get a drawable game component. There's a reason for that when I actually point at the code, I'll explain why. But just know that by default. When you add it, there's to the main game class, there is a components collection. You just add or remove components as you would to any other. It's a generic list. Every time it's added, your game calls update. After it calls update for everything in the component collection. Then it calls draw. Then it calls draw for everything in the component collection. In theory, it does it in order, but you can't guarantee it. It's one of those nice things like that. So the advantages of components is that you can segregate your code. You can see what's going on easier because I actually did a version of this talk where I did not use components, and I had an update 500 miles long as I was manually manipulating every object. You can really see what's going on. You can actually 100% fine-tune when everything's going on when you do that. The disadvantage is you then have huge spaghetti code. Audio. Audio is just a piece of content, just like a bitmap or anything else. You can natively, to the contents project, add a WAV, an MP3, or a WMA. Then there is a sound effects class. You load the sound effect just like you would load any other content, and you play it. Notice you can play it. There's no stop. There's no cue. There's no nothing. You can play it. If your sound is pew because they hit the A button to fire a bullet, not a big deal. If it's the background track for the level, you just have to let it play till it stops. So how do you get around that? Well, then you have XACT, which is the cross-platform audio creation tool. It is actually a separate tool. I am not even going to try to touch it in this talk because it is highly complex. But you can do also, you add your MP3s, you can find cue points in them. That's where you actually get play, stop, cue up specific areas where you can create your loops, all that other good stuff. Once you have it, you just load those pieces into the content, and then you can actually cue into it. I might, at some point in time, propose a talk somewhere that actually goes into XACT, but if you just open the, matter of fact, I'll open the screen of it just so you can see it. But it's really cool once you learn it. Notice it had its own monitoring or performance monitoring tool. That's auditioning utility. There it is. Yeah, it has its own performance monitor. Yeah. But that's what it looks like. Isn't that fun? But yeah, you drag your sound files in there. You can actually manipulate the properties of them. It's a very powerful tool. You get very good access to the sound. It's just expect to spend some time learning it. Oh, it's time for a demo anyways. All right. So let's bring up Visual Studio. Why are you still there? We already have it open. This is the sample game for our project. We call it, if you've ever read any of the old XNA books, I stole Rock Rain as the name from their examples, but this is in no way that sample code. It just was a convenient name. So here's our main game class. Your normal parts that you would think of, there's your constructor. We'll actually go into what each of these are individually in a moment, but there's the initialize, the load content. Notice that there is not a unload content because nobody ever uses it. there's the update, and there's the draw. Okay, let's step through this stuff one at a time. When you begin, you're going to get a couple global game objects. These are actually created by default when you create a new project. I guess I can do this. Yes.
Can you zoom in?
Oh, I always forget about that. Is that good? You want one more?
Maybe a little more.
All right. Just for reference, I will actually say go to New Project, and there is a XNA Game Studio section, and you've got your Xbox 360 game library. You can, and then you can actually make custom content projects. So if you needed something other than a bitmap or whatnot, you can actually create a custom project that would tell it how to turn that into something useful. So that's where those are during installation. Worth mentioning, this is part of the beta toolkit that just came out, the Windows Phone Rich Graphics application. So you might not see that by default. We had all sorts of fun talking about beta software in the other talk, let me tell you. But anyways, you get your sprite batch, and then there's your graphics device manager. Remember we were talking about the graphics device earlier? That's where we create it, and then it tells you where the content is, and okay, maybe it's actually in initialize. It uses that to, sorry, it's not initialize, it's in load content. It uses that to create sprite batch. So those are your global game objects. And then I've got some variables that I keep track of. There's my font so I can render the score, and then I keep track of what game state the game's in. I did that so that as we were going through the game, all I did was create a very plain and simple enumeration. So, loading, splash screen, menu, play, pause, game over. Why did I do that? So that my update loop can then call an update function that's appropriate to what I'm doing, so I don't have 10 million miles of code. Then I have some things so I can keep track of the asteroids when they're falling down from the screen. I've got some things that handle the splash screen. I keep track of the controller states. I'm going to show you that trick here in a second. And then I've got some just shortcut lists. This is all stuff that's actually in the game components. However, another one of those things where people will tell you not to use game components is now you have this huge list of game components, and if you need a specific one, you can't get to it. This will become obvious because in my little space game, I have some stars twinkling in the background, and I make 100 of them. That means if you've got 100 things on the screen, you've got the player on the screen, you've got 5 asteroids on the screen, and you got 100, you've got 6 bullets on the screen. That means if I want to find the player, I have to look through 120 items. So I just maintain a pointer to them. I mean, as long as it's a class, you're just storing 132-bit integer, it's okay. The reason I say it that way, XNA loves using structures. Anybody know what a structure is and why a struct is different from a class? This is like your brownie point question for the day. Classes are stored by or passed by reference. Structures are passed by value. That means structures are created on the stack, not on the heap. You start creating too much thing on the heap, then you run the risk of the garbage collector showing up, and all of a sudden your game freezes as it cleans up garbage. So be careful if you start doing too many objects and releasing them and creating them. I completely throw caution to the wind for this academic example, and I dispose of and create objects willy-nilly. Normally you would actually want to create 5 asteroids per se, and when you shoot one, you say take them out of the component list and hold the track to them, so that when you need to create another one, you just put that one back, so you're not adding and creating so many things. You want to minimize things like, even though I'm doing it in here, formatting strings raw, because then it creates a copy of the string on the heap. Silly things like that. If you want to get into hardcore game development, you need to learn the way memory is handled, because it does a lot of strange things. Back to our game. I wrote 4-player support in here. I don't actually use it, but I have controller 1, 2, and 3, and 4. I created this class that I've put into several other places. I even use it in my Windows Phone game. That just basically handles, okay, are you going up, down, left, right? How much up, down, left, right are you going? Did somebody press pause? Did somebody fire the gun? Did somebody press the back button to exit? It's a standard interface. Then I can create classes that handles the a controller, handles a keyboard, handles the touchscreen on a Windows phone, and then that way I can just kind of reuse my class. I am a big fan of doing an interface trick like that because, for example, you can then start writing, handling gamepads on the computer that way too, and you can just you can query for whatever input device they're using and then have one way instead of having miles long of doing stuff. As far as the actual controller goes, we've got the controller control state. I keep a value in there for invert X and Y just for academic sake. But here's where I just doing a private set to get based on my control panel. This is a game component. That way it's automatically, every time updates call, it comes through here. And in its update, it's going to keep track of what's actually going on. Let's actually get to this in detail. So I'm storing which controller I'm on, and I'm controlling what the gamepad looked like previously. If you recall, I mentioned that when you press a button, you just see it's pressed, which is good sometimes. But if you're actually trying to get a button edge, when they press the button or when they release the button, you actually manually need to query it, thus why we're keeping the previous control state. The initializer just takes the controller input in, and it gets the current state on the first one just so that I can say I have a starting point. Oh, because I wrote this as separate code separately. So when we start, you see I get passed in, this guy gets passed in the control state, which is actually from here. And then he also gets the previous state. This was genericized code I pulled somewhere else, which is why it's not actually an update. So from the left, I grab the current control state. I say, give me the left stick. Give me its X coordinate. What this does is, drag and drop. What this is for is, have you ever seen in games like I know Halo actually has it where you have a controller sensitivity? Because keep in mind, what does this return? Well, no, but it returns from -1 to 1, which means if I were to just pass that float to the screen position, then it means every frame I could only move up to 1 pixel. Not very fast. So to speed the game up, all I do is I take that analog value and I multiply it by 5, which then makes it have a bit of weight. If you actually wanted to make a controller sensitivity, then that's that little part right here. That's what you'd be manipulating. The minus is because it has to do with the way I would actually, if I were me, I would rewrite this class, but it had to do with what I was doing at the time. Left, it's I know I'm going left because I'm getting a negative value from the controller. Thus, I'm saying give me the value from the controller only if I'm going left. However, I need left to go minus. I need a positive value. I need to say I'm going left positively, so I have to invert the control stick. Play that sentence in your head with the math and it makes sense. Or even better, download this code later when you have your Creator Sculpt kit and step through it like 3 times and it makes complete sense of the way I'm manipulating those numbers. But I do the same thing down here, and it gets even worse because here's the way I do it if you have an inverted x-axis, and here's the way you do it if you don't. But all that is it's taking that float value and it's manipulating it to where I'm saying, okay, I need to go left 4 pixels, I need to go up 2 pixels. Then I come down here and I say, hey, if the A button's pressed, see if it was previously released, and if it was, then they actually hit fire. If the A button's not even pressed, then we know they didn't hit fire. So in that update, they're not firing a button. I do the same thing for the start button, so I know whether or not they paused it, and I do the same thing for the back button, so I know whether or not they're trying to leave the game. And then that return the control state just is, then it's turned into the previous control state for the next time through update. It's fairly plain simple. You're going to have a code like this to update the player in almost every game, somewhere. That code is going to exist. How you do it is up to you, but that's your standard manipulating the controller. This stuff down here is like kind of shortcutting it to where if you just said, I want a controller 1, it recalls it by itself. So that's where I'm wiring up all the, in my initialize, I'm wiring up all those components to actually control the thing. Again, okay, load content. This is where you're actually going to load all those pretty pictures, in theory. It creates our default sprite batch. Here I load a logo from my company. I give it a place on the screen. Notice I'm asking the viewport for the size. Why would you want to do that? One, if you're dealing with, well, either with Windows or with Xbox 360, the size of the viewport on the screen could change based on the screen resolution. 1080p is 1920 by 1080 resolution. 720p is something smaller by 720 resolution. I don't remember the vertical on 720p. So you can actually, if they're smaller resolution, you can kind of figure out where you're going and do everything relative that way. You'll end up doing a lot of relative math in game programming in general. But here, a vector 2 is there's two classes you're going to see all over the place. You're going to see a vector 2. That is a simple x and y vector. If you've ever played with the vector in math, it's just a vector. It's stored as a structure, so it goes around on the stack, no problem. Create them, use them, abuse them willy-nilly. This guy here, I don't know if you can see it. Let me find a definition of him. It should be in here. This is a texture 2D. A texture is basically a bitmap, but the reason why it's called a texture is because if you're doing 3D programming, you would create the polygon, and then you would paint the texture on top of it to color it. So, for example, if you're like every game has crates in it, except for my game. Every game has crates in it because that's where you have to shoot to get your power-ups, right? So, you would just create a box, which was a wireframe, and then on each side you would paint a texture, which was the picture of the crate outside. So that is what a texture is for. So here I'm just pulling out that image, and I'm pulling its location, and then I've got the code stock logo. I do the same thing. I've got to quit doing that. Here I pull off a score font. A score font, guess what a score font is? Well, I'm sorry, what a sprite font is, because the class is a sprite font. It is actually, here in my game content, an XML file. Because that makes sense, doesn't it? What it's actually doing is interesting, though. You tell it the name of the font you want. You tell it the size of the font. You know, your standard type of font things you would care about. The weird part at the bottom, like here I made it bold. The weird part at the bottom is you get this thing called the character regions. And you can define a set of character regions on that font. What happens is you're not actually loading the TTF file. What you're doing is you're saying, I need a section of the font rendered as bitmaps so that later when I try to draw a thing, it puts all those bitmaps together. Make sense? So this is telling me, start at 32. Who knows the ASCII character code sequence? Anybody? Any true geeks? You do? Do you know what 32 is?
Space.
Yes. You know what 126 is?
65 is a circuit.
Yeah, it's a little past Z is the idea, though. It's most of the printable characters from the non-extended ASCII character set. Because you're storing now 32 minus 26, 94 images, all of 12 point, so roughly, depending on screen resolution, 15 pixels, or I'm sorry, other way of the math, roughly about 9 pixels high, 9 by 9, all the way across, because I'm using a fixed point font. That's a really big image it's now carrying around. Well, if all I want, and granted I'm using some text in the game, but if all I want is the numbers 0 through 9 so that I can paint a score on that font, I can limit that down to just those characters to reduce that size. I was doing a version of a Windows Phone version of this, and I tried to use the tab character, and I forgot about the actual character regions part, and of course, by default, you don't get tab. So if you do a \T and you try to render the string, it goes, what's a tab? Again, one of those strange errors it takes forever to find. XNA is really good about giving you strange errors. You'll become a really guru. And then to create stars, like I said, I have 100 stars twinkling in the background. I actually do that in a background thread while the splash screen is running to save time. All I did was create a thread. It comes down here, and it creates a new star. We'll look at the star object in a second, and it adds it to the components array. The components array is almost, it's like I said, it was earlier. It was pretty much meant for like that update type thing for the control state, because you're always going to want it. It just runs in the background. You don't have to worry about it anymore. These stars are another prime example of where you would want a drawable one, because you don't care. We'll get more into this in a second, but when you draw the stuff on the screen, the order you call it in matters, because it's going to put it on the screen, and then if you put something else on top of it, the last thing called is on top. Those stars we really don't care about. If the screen goes over them, the screen goes over them, it'll actually add a great unintentional depth of field, blah, 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 blah. So we can just tell it, run in the background, we never want to deal with them ever again. So that's a kind of really good area to use a component. Some of these other places I'm using components just because it separates the code, makes it easier for you to see it. So now that we're done loading everything, we can actually start the game proper. My update method, all I'm basically doing is I say which game state I am and run these other ones, so we're not going to look at update anymore. When we start with the splash screen is on screen for 5 seconds. So all the splash screen does is it says, hey, when the game time, this game time object, gives you all sorts of information about the game that's actually running. When the game time object says that we're actually have gone 5 seconds, you're done with the splash screen. That's an animation that's actually being controlled somewhere else. But all it does is it says, hey, wait 5 seconds, you're done with the splash screen. This game time object is a running timer of what's going on in the game. Most of your animations will be timed against game time if you're actually running animations. How am I doing on time? Okay. I'm running out of it fast. If you're actually running animations. So what's going to happen is you get 2 important pointers in it, and then a third one that I'll show you a reference to in a second. But you get 2 important timers. You get your total game time, which is the total amount of time it's been running. And yes, you can reset that game time back to 0 for when they start a new game. And then you get the running game time. Where do I use running game time later, so we'll actually see it being used. But it is the amount of time that has passed since the last time that the specific function has been called. So if you're in update, it's the amount of time that passed since the last time update was called. If you're in draw, it's the amount of time that's passed since the last draw was called. My menu code is very simple. If they press start the game. Here's where I reset that game timer. I add a new player. I say play, and then I say we want to immediately throw an asteroid on the screen. That's just a time span. And then if they press the back button, exit. That's everywhere. The pause menu, if they hit pause during the gameplay, just because we're going to spend a lot of time in update game, if they hit pause, then disable the player, disable all the objects. That way they're not moving while you can't control them. While you're paused, if they back out of the game, exit. If they unpause the game while they're paused, re-enable everything and set the game back to play. Pretty standard. The reason why I disable everything here, there is one event that will drive you crazy. It's the one event you can't control. There's more than one way to not control it, but there's one event you can't control. It's called the game being disabled. If you're in Windows, it's when the game doesn't have focus. If you're in Xbox, it's when the guide button's pressed. Okay? You want to be able to handle that because all of a sudden the player lost control of the game. This is handled by 2 events, on deactivated and on activated. So when the game is deactivated, aka they press that button, that code gets called. So in here I can say, hey, if they hit the guide button and we were playing, pause it. That's why I stopped all the game states in pause. And then they can unpause it themselves. These are now the 2 functions that are unintuitively named, so you'll take forever trying to find. while I'm up here, because I showed you adding the components earlier, I'm maintaining these little lists, so I don't have to do everything more than once. When a component's added and I put it into the components list, I automatically add it to my little helper list, so I don't have to do it more than once. If I remove a component, I automatically remove it from my helper list. If they want to do it for me, I'll let them. Okay, back to the part where the fun happens, the actual game. So like I said, this is basically an asteroids type of game, of what we're going to look at here in a second. You've got a player on the screen. The player can move around. If they press the button, he'll fire a little shot. Asteroids are falling from the top, from random areas. If he shoots the asteroid, he gets points. If he gets hit by an asteroid, he loses a life. He loses 3 lives. It's game over. So the main way this game's done, well, I've actually got, in our example, most of that update moving code actually handled in the game components of those objects. But there is some stuff that I need the game itself to keep track of. 1, if they exited. 2, if they hit pause. I need to keep track of when to create a new asteroid. So what I'm doing here is, if you remember I had that time to next spawn, every time I come through, I say, take that time span and subtract the amount of time it was since last time you came through here. And then I say, if the time span is greater than or is less than or equal to 0, I don't think you can have negative time spans, but it doesn't hurt. If once you've expired all that time, create a new asteroid. The actual creation code for the asteroid will randomly place it on screen and everything. And then tell them to wait another half a second till you create another one. If you wanted to, and you wanted to say, hey, as the game goes on, you could pull the total time and make them, come more frequently over time. I actually had a version that did that once, but discovered it just didn't add enough to the game to make it worthwhile. The other thing you want to do outside of those components is here I have collision detection. I loop through all my asteroids. Notice I don't have to go through the game component, so I don't have to get 100 stars out of the way. I look at all my asteroids. I look at all my bullets. I say, one at a time, if the bullet and the asteroid's images are intersecting, give the player 1,000 points and get rid of those specific objects. And then that event or that trigger I showed you earlier will actually remove it out of my list. After we've had all the bullets kill all the asteroids, we then say, okay, now go through all the asteroids and see if any of them hit the player. If they did hit the player, remove the asteroid and remove a life from the player. The player, when you remove a life, actually has its own code that says, hey, you took my last life, and it will throw a game over exception. If the game over exception happens, then we remove the player from the screen, we remove all the asteroids, we remove all the bullets, and we put the game into game over. Oh. Yay. Yeah. Come on, we need some excitement. It's almost lunchtime. Food! Thank you. All right. We've got draw code here. Here's my splash screen. For the splash screen, make the screen white, start a sprite batch. If we're in the first second, don't do anything. If we're in the second, wow. What I'm doing is part of the sprite batches, you can pass in the opacity of the object. So I have my solid bitmap, but I change its alpha value, and every time from the first second to the second second, right here. Remember that color? Oh, we haven't talked about that yet. But there's this alpha blend section where I'm actually saying, okay, take the seconds from the game time, do a little map on it so I can make sure it's between 0 and 1, and change the opacity based on the timing. So it fades in. Once that one's in, just continue to show it, put the other logo in a second later, just show them both at the end. Get done, return. Fairly straightforward. It's a nifty effect, and it's kind of like I felt like if I was doing a demo other people were looking at, I should have put it somewhere. Here's the fun part. Here's our actual, we're in the game. Make the screen black. if we're in game over, we need to draw game over to the screen. There's this, by default, when you draw a string, you don't know how big the string is. So they give you this function as part of the font called measure string. You can actually give it whatever you're about to paint to the screen, and it will give you a vector saying its length and width. So you can actually use that to position it. So I can get a vector with the position, or I call it position, but it's actually just the length and width, but with the position of that game over string, so that then I can come here and I can center it on the screen. Same basic idea with, hey, let's start the game. Same idea with the paused indication. I draw the score and the number of lives. This is here because I was doing a part earlier where I was querying Xbox Live with the gamer tag, but there's issues with that. And then I end it. So what do you notice I'm not drawing to the screen? Anything useful? Good answer. Good answer. All that is hiding in my game components, because remember I added all those game components. Let's look at those real quick, and I think then we'll have just enough time to actually see the game run. So let's look at the star first. So if you remember, I set this one up. This one's actually the way you'd want to do one. Every time you create a star, this update order means do it way at the last. This is your, don't even worry about this guy if you have to. Remember that flag I also talked about is running slowly? Did I tell you how is running slowly is called? Why it's called? Yeah, I did. But yeah, it says that if the game's running slowly, you don't need to worry about making stars twinkle, which is what the update for star does. It's another one of those classes that was kind of added because I needed a reason to show you something else. But that will actually tell it, hey, look, this is the last thing you need to worry about if the game's running slowly. Catch up. When we load the content here, I pulled this random number generator out, and I have this thing called frame, besides its normal position, and I also randomized the color. But I have this guy called frame. Now what the frame is the way you would control animations normally is if you wanted to have an actual animation, is you don't want to load each individual font or each individual picture individually, because then you have a lot of objects laying around. So what you do is in my content project here, if we look at my star, notice I have each state of the animation in one picture. So there's a 5x5 section here, and then a 5x5 section here, and then a 5x5 section here, all the way across. What this allows me to do is then I can pick a random frame. When I actually do my draw, I can say, give me one frame of that animation. This is just a rectangle saying I need this section of that sprite map, and I only need to show that part of it. So I'm just only showing that part of the one globally loaded object. And then, of course, there's its position and the color, which is all being randomized and handled here in my update. So what the star object basically does by setting it and forgetting it is I have this image right along, and I can say, show this part, now show this part, now show this part, now show this part, now show this part, and it goes all the way to the end. When it gets to the end, it then says, oh, okay, this star is dead, so I'm going to move it to a new part of the screen, change its color, and start it from the beginning. And it just runs in the background and looks pretty nice. I don't ever have to worry about it again. Cool, huh?
Nice.
Yay.
Genius.
Now, you cannot do stuff as nifty as that with some of these other parts, even though I do it anyways. So, let's look at the asteroids first real quick. They're pretty straightforward. Asteroids, when they're created, not only do they have to pick a place to randomly start at, but they need to tell themselves which direction to go. So not only do I pick a random place off the top of the screen, but then I also pick a random slight XY position and a speed down. It's an example where I'm using a vector actually as a vector, so that when we actually update it, we say, hey, take your current position, add your path to it, which will move it down the screen. I then say, if you fell off the screen, get rid of yourself. You're dead. The draw method just draws himself. The bullet looks almost identical, except for its path is pretty straightforward. I didn't create it as a... So it just says, hey, go straight up. And if you hit the top of the screen, get rid of yourself. just about the exact same. It keeps track of its player. I did that originally because if it was a multiplayer game, it would know which player shot which bullet, so it would know who to give the score to. And then the player. The player's got some extra stuff in it. So he's got his texture. He's got this little constant that says, okay, we'll give him an extra life every 30,000 points. I guess I keep forgetting that it's not doing it by default. We'll give him an extra point every 30,000 points. We've got his position on the screen. We've got his score. The score, quite plain simply, if you ask for it, it returns it. It adds this. If you give it the score, it adds the score to it. If the score is greater than the total number of points you need for the next life, it gives you an extra life, and it ups the next time you need to get an extra life. Your lives, standard return, standard value. If you run out, throw the game over exception. Load content and starter, everything you would think they would be. Notice he gets passed in a reference to his controller, which is automatically updated in the fact that it's a game component, so he doesn't ever have to worry about it. He just knows that every time I update calls, I can check to see what the controller told me to do. So let's check to see what the controller told me to do. Take that right position, add it to the X position, subtract the left position from the position, add the up, subtract the down. All magically handled by the fact that I have a class that's managing keyboard state and controller state and whatnot. So it makes this look a lot nicer. Don't have to have multiple code sections for how the controller input is. Just like the asteroids and everything else, don't let the player fall off the screen. It's just slightly longer because he can move in any direction. He's not moving just strictly straight down or straight up. And finally, if they press the fire a bullet button, fire a bullet. I make bullets cost 10 points because I'm mean. But you get scores just for staying alive, so every time the player stays alive, he gets points. And then draw that out. That's it in a nutshell. That's the entire game. Can you handle that? Everything look good? Maestro.
I don't have a certification for this, so I'm not sure.
No! Okay, so here we are. Like I said, this is actually my gamer tag. Feel free to shoot me if you wish. So once you're in here, where are we at? So we can go into the game library, and there's the precompiled version of this code. We go into all games. Then here's that XNA Game Studio Connect program I was talking about. If I had another 2 minutes, I would find it in the marketplace for you, but we're running low on time. So let's launch this guy. This is what he looks like. If we actually wanted to connect to another computer, that's where it gives you the code that you then add to the game connection center I showed you. Anyways, oh, I didn't mean to exit it. But that's the program you actually need to open to have it open. Go back in there. The beauty of being in this thing is that you can actually debug a program. So I would actually put a breakpoint in here and show you breaking, but we'll have to do it kind of virtually. So it's waiting for a connection. Here I'm showing that my deployment I want to be to an Xbox 360. So if I hit F5 on here and it builds it successfully, then it says here deploying, and then it pops up. There's my little animation I talked about. There's all my sparkling things and everything. Just to prove a point, let's put a breakpoint for when I die, just so you can see it stop. Hit F9. I've just got a standard breakpoint in here, so I'm starting the game. Oh, because we set it at the beginning. Okay, there we go. You fire around. If I lose a life, hit my breakpoint. And then if we die, close everything out and says game over. Simple, right? And then if you back out, it actually comes out. If you remember earlier, I was playing around with networks and complaining a lot. You actively have to be connected to Xbox Live. It has to be able to hit the server and validate your Creators Club account for this program to even run. So if you are not on Xbox Live at the moment with a network connection, you are not going to get on. Now, the way I'm doing this, just as a thing, this is a crossover cable going into my laptop, which is internet connection sharing with this Wi-Fi. So I get the nice, fast speed of a wired connection, but I'm still connected. Any questions? Can we get some hooting and hollering? Yay! And we will put up my any questions slide. Any questions? Here's all my contact information. Feel free to send me anything.